In this video, we're going to look at trig properties. Let's take a look at the unit circle again. We're going to draw a radius with a length of 1 being the unit circle, and it forms our triangle, of course, with our side lengths of x and y, and angle theta. This has the ordered pair, x comma y. And if we wanted to set up our ratios, we can again say with our right triangle that cosine of theta is equal to x over 1, and sine of theta is equal to y over 1. That leads us to conclude that x is really the same thing as cosine of theta, y is the same as sine of theta. Well, knowing that, if we have a right triangle, we know that with any right triangle, it always has the same property of the Pythagorean theorem, where x squared plus y squared is equal to 1. In this case, we would normally see r squared, but our value is 1. Well, if x and y are cosine and sine, then we can establish a new identity saying cosine of theta squared plus sine of theta squared is equal to 1. Or the more standard way that people write it is typically seen as sine squared theta plus cosine squared theta equals 1. It's this equivalent value. So this is our first trig property, one that we will be using quite a bit in this semester. As we take a look at that identity, sine squared plus cosine squared equals 1, I encourage you to look for two more trig identities. These identities can be found by manipulating these equations just a bit. For example, if you want to make a new identity, you could divide everything by cosine squared theta and get a new identity, like this. Or you could also divide everything by sine squared theta and get a new identity. So I encourage you to find those two other identities. Let's go on and take a look at another property. We'll do these others in class. We'll work on them together. Here we are, exploration 6, even and odd functions. So as we take a look at our trig functions, very similar to what we saw in earlier chapters, we know that an even function is when if you plug in a negative x value, you actually get a positive y value, right? So f of negative x equals f of x. And if it's odd, we know that if we plug in a negative x value, we actually get a negative y value. So let's see how that plays a role into sine and cosine. As we take a look at the diagram here, we see that given angle theta, we have the point xy. Now, if you made that theta into a negative, you went the other way, you went clockwise instead, then notice what happens, that the y value has now gone to the bottom portion, it becomes a negative y value. And remember how y represents the sine value of your trig ordered pair. And then the x value represents the cosine value. So therefore, what we're seeing here is that when you have sine of theta giving you a y value, but then sine of negative theta is giving you a negative y value, that's showing you that this is an odd function. Okay? And it's odd because sine of negative x is giving us negative sine of x. Now, if we look at the cosine function, remember that the cosine is really taking a look at the x-ordered pair. And notice how the x-ordered pair doesn't change. It stays the same. It's always going to be positive regardless of whether theta is positive or negative. It always has the same x value. So therefore, for that reason, cosine functions are even, because what we see is that the cosine value of the negative x still gives us the positive cosine of x. Okay? And because we have sine and cosine, that will also allow us to establish tangent. So as we take a look at the box down below now, we can see that sine of negative theta is going to give us negative sine of theta. It's an odd function. Likewise, because cosecant is this reciprocal, we also know that cosecant negative theta is the same thing as negative cosecant theta. Cosine negative theta is even, therefore that'll give us cosine of theta. And likewise, because secant is this reciprocal, we're still going to get the same value, so it's still going to be a positive value of secant of theta. And one thing that we learned before is that tangent is really the same thing as sine over cosine. So you can imagine that if what we have then is really sine of negative theta over cosine negative theta, well, one being odd, one being even, we know that we're going to end up getting a negative over a positive. So tangent is also considered an odd function. Tangent will be negative tangent of theta. And likewise, this reciprocal will give us negative cotangent of theta.